Math challenge, a parabolic quest. Behold the mystical curve. You've stumbled upon the mighty parabola, y equals 6 minus x squared. But lurking nearby is a lone traveler at 0, 2. Your mission is to find the closest point on this parabola to this traveler, who's at 0.2. It'll make this traveler's job easier. So here I have an XY chart. There's the point 0, 2. And to begin with, let XY be any point at random on this XY chart. Using the Pythagoras theorem that each side squared added equals the hypotenuse squared, d squared equals x minus 0 squared, and this height is y subtract 2 plus y minus 2 all squared. And therefore, d would be the root of this whole equation. But I'm going to keep it as d squared equals, because if we minimize d, it will be the same answer as minimizing d squared. And d squared will be easier math than working with a root sign. Now, this is for any x and y point at random, but we're looking for one specifically on this parabola. Now, if you remember, the equation is y equals 6 minus x squared. That means anywhere on this parabola, for any x value, the y value will be 6 minus x squared. So if I make up any number at random, the number 3, where x equals 3, on the parabola, the y value will be 6 minus 3 squared. So I'm going to do is substitute in. Instead of using points x, y, I'm going to use x and 6 minus x squared, because this formula is any x and y at random. Using this is any point that's on that parabola. So that x remains x. Instead of y, we're going to say 6 minus x squared subtract 2. And now we simplify a little bit. X minus 0 squared is x squared. 6 minus x squared minus 2. 6 minus 2 is 4. 4 minus x squared. You'll see what seems a bit confusing. I've got an arrow here and an arrow going down. As this is a calculus question, I'm going to find the derivative. And there's two routes we can take. We can use this equation, simplify it, and then find the derivative. Or we can find the derivative and then simplify. It makes no difference. Both are correct. So I'll just, seeing I'm working downwards, I'll do the derivative method first. And I'm just treating that d squared as a concept. That derivative, the derivative of x squared is 2x. And we have a bracket to the 2. It's a chain rule. 2 times the bracket to the 1. I don't have to write that 1 in. Times derivative of the inside, which is minus 2x. And now we just simplify. I rewrote that 2x. Minus 2x times 2 is minus 4x times this bracket. And now we multiply this bracket to simplify. Minus 4x times 4 is minus 16x. Minus 4x times minus x squared. 2 minus multiply, make it plus 4. X times x squared is x cubed. And our 2x's over here, 2x minus 16x gives us minus 14x. And that 4x cubed I wrote at the front. And if we took the other method, we would have landed up with the same answer anyway. So from here, we're going to multiply that. We're going to take out a common factor of 2x. We have a derivative. That's the derivative. We're setting it equal to 0. And for 2x times a bracket equals 0, it's just like saying that bracket times 0. So we've got 2x minus 7 equals 0. 2x squared equals 7. We divide each side by 2. What we do to one side, we do the other. X squared equals 7 over 2. So x will equal the plus or minus root of 7 divided by 2. Two decimal points is 1.87. This question didn't specify about decimals or fractions, so I can even simply, if I just leave it like that, remember the equation, if I go back to the original equation over there, y equals 6 minus x squared. To find any corresponding y, we have to plug in there. So if we go back here, y will be 6 minus plus or minus root 7 over 2 squared. When you square it, that will become plus. That minus will make it minus. So 6 minus 7 over 2, which gives us, if we simplify, it's 5 over 2 or 2.5. And the 2 points on this parabola is minus root 7 over 2 and 2.5, or root 7 plus root 7 over 2, 2.5. Those are the points on the parabola closest for this traveler. And I wrote it out, I guess, neater over there. It's these two coordinates. Thank you for watching. And a reminder, I have 3 YouTube channels: Variety and Fun Math, Martin Tutorials, and Martin Talks. You are encouraged to subscribe to all 3. Thank you for watching.